Okay, so let's go to number 12. And number 12 asks, a fitness club has 100 members. So 60 of them swim, represented by S in the Venn diagrams, and 70 cycle, represented by C in the Venn diagram. 25 do not swim or cycle. Okay, if you know Venn diagrams, this is it's definitely going to be an easy one. But anyway, let's just see how to handle this. And we're just going to start with the ones who do not swim or cycle. Where do we put them in the Venn diagrams? Usually outside. So we're going to put them here. This is 25. And then I want us to look at those 60 who swims and those 70 who cycle. I want you to know, like in a case of Venn diagram like this, just keep in mind there will always be those ones who do both activities. Okay, so we're not given the information, but somehow you're like supposed to know that. Okay, so because we don't know them, we're just going to put them here, and we're just going to use X to represent them. You can use any letter, but X works well. So just going to say X are the number of members who do both activities. They swim and also cycle. So this means those who do swimming only can be represented as 60 minus X. And those who do cycling only can be represented as 70 minus X. And now it gets easy to find out what X is. Once we find what X is, it's easy to find those who swim only and those who cycle only. And to find the value of X, just remember we have 100 members. 25 of them don't do either of the activity. So we're only remaining with how many? 75%. So those 75%, we know they're represented by S and C, swimming and cycling, right? So we can basically add everything here, and we know that should add up to 75 members, right? So we'll do 60 minus X plus X plus 70 minus X is equals 75. So let's find out what X is and be able to complete our Venn diagram for part A. So 60 plus 70, I believe that's 130. This minus X here plus X, that's going to be 0, so it's going to cancel. So only remaining with this minus X here, and all of this is equals to 75. To find X, we can actually take this negative X to this side becomes plus X, and this 75 to this side. And then we have 130 minus 75 is equals X. And you can clearly see 130 minus 75, that I believe should give us 55 if I'm not wrong. And we know X is equals 55. So that means the members who do both activities, we have 55 of them. And if we have 55 of them here, we can only like now get for those who cycle only, which is 70 minus 55. I think that's 15. And 60 minus 55, I believe that's 5. Okay, so for part A, it says complete the Venn diagram. Now, okay, our Venn diagram is complete. Actually, if now we remove this, we can have a complete Venn diagram. So that's how it looks like. Okay, so 3 marks, we've gotten them that easy. Okay, nice. So let's move on for number 12B. So this one says, one of the members is chosen at random. And for this member, find Roman 1, the probability that they cycle. So this one, we're just going to pick all the members that cycle. So basically within that diagram. And we can see there are about 70 of them, 55 plus 15. There are about 70 of them out of 100 members. Of course, you can simplify this, and then you can write 7 over 10 here. Okay, that was easy. And then we go to the next one. So we are told to find that this member, the probability that this member does both activities. That is, they swim and cycle. Remember, intersection means the region that they share. So the region that they share, we have 55 members. You can see that region here. So that's 55 members. All right, 55 over 100. If you want, you can simplify that. I always like it when you simplify, and most examiners like that. So by 5, you get 11. By 5, you get 20. So we have 11 over 20 here. And then Roman 3, we want to find the probability that this member swims union not C. Okay, I like reading it as not C. You can also read S union complement or C complement. Okay, basically I always read as not because it kind of like gives a clearer picture. Not means not that. Okay, I hope that makes sense. But anyway, what this means, it means I only need the members who don't do okay, let me see how to frame this better so that you can understand it. So S union not C. So we are going to only ignore the members who do cycling only. Make sense? So usually this is what that means. S union not C. Always take that as those who don't do that activity only. And clearly, if you go back to our Venn diagram, we can see that the people who do only cycling, there are 15. So these are the members we are going to omit. I hope that makes sense. Like if I would shade this, I would shade everything else, just omitting or ignoring. Let me just like grab this so that you can clearly see. Okay, I've grabbed it. So if I would shade this for that condition, I would shade it like this. This would only leave this because it says the probability of swimming union not C. Okay, so we're only going to omit 15. So that means the rest are 100 minus 15, I think that's 85, right? So you can put 85 here over 100, and then we can simplify this by 5. I believe that's 17. By 5, this is 20. So you have 17 over 20 here. Okay, so in case there is something that is confusing on Venn diagrams here, please, maybe you might want to revise that. If you need a video, I'm going to be making a video shortly on Venn diagrams, but I think that's how you handle those questions. Okay, perfect. So let's go to number 13. And number 13, we have m is equals 2 power 7 times 3 power 3 times 5 power 2. So and then we are told to write 14m as a product of its prime factors. Give your answer in index form. Okay, first of all, we know m is already written as the product of its prime factors, right? You can clearly see them here. So we just need to find the ones for 14. And 14 can be written as 2 times 7, right? Because 2 times 7 is 14, and those are the prime numbers that make up 14. And therefore, times now the other values for m, this is 2 power 7 times 3 power 3 times 5 power 2. And then we can just like gather those with similar bases together. So this is 2 power 1, and then we have power 7. And if you know the rules of indices, if they have a similar base, we can just add the indices. That will be 2 power 8. I'm just going to write the prime numbers in ascending order. So 2 power 8 times 3 power 3 times 5 power 2 times 7 power 1, which is 7. And that will be your answer. Okay, amazing. So let's go on to number 13b. So for 13, we're told R is an integer. So if you know what an integer is, this is a whole number that is either negative or positive. But remember, it's a whole number, not a fraction, not a decimal. Okay, so that information is important. And then you're told m divided by r, or m over r, is a cube number. We are going to get a cube number when we divide m with r. Okay, interesting. So being told, find the smallest possible value of r. Remember, r is an integer, okay? Very important information. So if you don't know information on numbers, please try to review numbers, try to understand integers, natural numbers, real numbers. Okay, yeah, very useful. Anyway, let's handle this. So we know m is 2 power 7 times 3 power 3 times 5 power 2. And then we're being told that is divided by r. R is an integer. We don't know what r is, but we can try to figure out. And we're trying to figure out the smallest possible value of r. So we want that value of r to divide m such that it gives us a cube number. Okay? So looking at what we have, 3 power 3 is already a cube number, which is good. So this means we're only left with 2 power 7 and 5 power 2, and we want to adjust them such that they are actually cube numbers. Okay? And of course, we want to adjust them in a way that we still keep r as the smallest possible value. So the first thing I see, I can adjust this. I can just divide by 2, by 2 power 1. Okay. The reason I'm doing this is because I know if I divide 2 power 1, 2 power 7 by 2 power 1, I know this will be, no, it will subtract and I'll get, if you know, it will be like 2 power 6. And 2 power 6, that's a cube number because the index, of course, I know if you try to do the cube root of this, you can actually get a cube root, right? Because this can also be written as 2 power 6, okay, power a bad. And you notice this can actually cancel this to be 2 power 2, right? Okay, rules of indices. I don't want to go so deep into indices, but these are some things like you should know. So that's why I'm adjusting this by dividing it by 2 power 1, so that when I divide, I'll actually have 2 power 6. I don't want to touch the 3 power 3 because it's already a cube, 3 power 3. So those indices make them cube numbers. So the other one I want to touch is this one. And I feel like, yes, I can adjust it such that it's 5 power 3, but then I will have to divide it by 5 power negative 1 here. Why? Because remember, 5 power 2 divided by 5 power negative 1, of course, this will give us 5 power 3, because remember, 2 minus negative 1 is 3. Now, the problem with that is if you know the rules of indices, this can actually be written as a fraction. And remember, r is supposed to be an integer because this can be written as 1 over 5. And this is a fraction, but we don't want that. Okay. So we realize if we try to adjust 5 up, we're going to get a fraction which is not something that r should be. It's an integer. So the only way I can just do is just eliminate the 5 altogether. Because if I do this, I'll actually get a 0, and I'll still keep my number. Remember, I'll keep my number like this, right? This will be basically the result of this calculation, right? And this number is actually a cube number, okay? If this doesn't make sense, we're just playing with numbers. We're playing with indices. So you kind of have to get really good with indices to be able to do this. Now, if this is the result, this means our r value should be this one down here. So which is 2 power 1 times 2, 5 power 2, 5 power 2, which is basically 2 power 1 is 2, and then 5 power 2 is 25. So the answer will be 50 there. And that will be our answer. Okay. Anything confusing? I can put some comment and then I'll try to check them and try to clarify. Anyway, so let's move on to number 14. So for number 14, we are told find the value of, okay, we have more indices here, but I think now you should you have a hang of it. So we know if they have the same base, we can just subtract the indices if it's division. So it will be 2 minus negative 2. Be careful with this. Remember, there is the minus because of the division, And also this number is already a negative. So you want to make sure you follow that. Usually negatives are some of the common mistakes people make. Please watch out for negatives. Okay, I always tell my students, this is one of the common mistake that people make. Okay. Okay. So anyway, let's that we know two negatives following each other should add up to positive or should become positive. Therefore, this will be 3 power 4. And we know 3 power 4 is 81 because 3 times 3 is 9. 3 times another 3, 27 times another 3, 81. So our answer here will be 81. Okay, good. For part B, we are told 16 power negative 3 over 2. Now, okay, if you know fractional indices, you know the denominator becomes the root. So we can say root or square root 16. Okay, it's square root because of 2. Okay, if it was another number like 5, it would be root 5. Okay, yeah, but because this is 2, it's going to be square root 16. And then after we do that, we usually know the numerator becomes the power. So in this case, power negative 3. So we know root 16 is 4. That's basically 4 power negative 3. And this can be written as 1 over 4 power 3. Okay, rules of indices. And this can also be simplified further to 1 over. Okay, 4 power 3 is 4 times 4, which is 16, times another 4, which is 64. So our answer will be 1 over 64. And you have your marks there. Okay, perfect. So let's move on. Okay, number 15, we are told to factorize x squared minus 64. Usually, when you get something like this, try to check if it's a difference of 2 squares. Okay, difference of 2 squares. Okay, yes. Difference of 2 squares means like 2 squared numbers subtracted. Okay, and we know from this rule, it means a minus b, a plus b. Instead, write a plus b, a minus b. Doesn't really matter if you have 2 square numbers being subtracted. So just to check, x squared, 64 can be written as 8 squared. And that's a difference of 2 squares, which means written as x minus 8, then x plus 8. So that will be our answer here. You can just write it here, x minus 8, x plus 8. Remember, it doesn't matter if you start with x plus 8, x minus 8, doesn't really matter. We'll still evaluate to the same thing. Okay, so far so good. Guess you're still confused, please leave comments. I love helping students. So leave comments below and I'll try my best to help you. Okay, so let's move on. We're told to factorize this. Okay, from the look of things, if you dealt with factorization of quadratics, you know this kind of looks very, very familiar, right? Like just ignore this 2 is there. Like you know this looks really familiar because we can say our quadratic has been factorized because we have common factors, which means we have like 2 brackets with common factors, right? Which show our common factor. Okay, but because there is that squared, we kind of have to like factor that in. So let me rewrite this. This is x minus 2y, and then plus 6. We're going to have 2 brackets which kind of look the same because of the square. Okay, so 6, sorry, not 6, but another bracket, x minus 2y. So this basically is the same as this x minus 2y squared. Okay? So what you're going to do, from the look of things, you can still look at this and this as the common factors, okay, or the common factor. So if you factor that out, we can actually write that here, x minus 2y, usually the factor, and then the other one is this one. The other bracket is going to be 5x, and then you're going to treat this as one thing, okay, 5x plus 6 x minus 2y. Okay, that's like two brackets there. Can open this inner bracket. It will be 5x here plus 6x minus 12y. And then this can actually evaluate, because this can add up, have 11x minus 12y. So the final answer will be x minus 2y, 11x minus 12y. So x minus 2y, 11x minus 12y. Basically from the idea of a quadratic factorization. Okay? Okay, perfect. So let's move on to number 16. And number 16, we have, okay, this diagram. It all is not drawn to scale. And we are told AB and BD are two sides of a regular 15-sided polygon. Okay. And AB and BC are two sides of a regular n-sided polygon. So that means we don't know the number. And then we're told angle DBC is 14. Okay, you can see that here. So work out the value of n. Okay. Before we find out the value of n, it's good to find this angle. Let's say we found that angle, we can add that angle with this one, and we can actually be able to find now the number of sides. And remember, when it says regular, it means all the angles are equal. Okay. Now, let's figure out what this angle, that is angle, we're looking for angle ABD. Now, for that angle, we already know, like, this is a 15-sided polygon, and it's a regular one. So that means if we can get the sum of all the angles inside this polygon, we can actually get that angle, because you're only going to divide it by 15. Okay? So we're going to divide the sum by 15. And the good thing about this is we usually have a simple formula we can use to get the sum of all interior angles in a polygon. And it's usually given by 180 into bracket n minus 2. Like this one you have to memorize, is usually not given in the formula sheet or in the formula section on this paper. So you kind of have to memorize. But it's a simple one to remember. It's basically 180 n minus 2, where n is the number of sides. Number of sides or angles. Okay. Now, if this gives us the sum of all interior angles, and we already have 15 sided, remember we can just put that 15. You can just put that 15 inside here where we have n, substitute it there. And then this will mean I have 180 times 13. So I can do that on the side very quickly. So remember, this is an uncalculator paper. I can just do this very quickly on the side. This is 3, okay, 5, 8, 1, that's 4. And then, okay, 3, carry 1. Okay, good. So, okay, remember the 0 here. Okay, so we know the sum of all interior angles of this polygon is 2340. So 2340 degrees. So this means if I was to divide this by 15, remember it's a 15-sided one and it's regular and all angles are equal. So if I were to divide that by 15, what do you think that will be? Okay, so you can just, you can use the long division method here, because again, it's an uncalculator paper. You can try to simplify it. Okay, I think I'm going to do it like really quick here on my head, and can divide by 3. Well, I can divide by okay, divide. Let me just do this. Okay, I think I give me 156 here. Okay, anyway, you can just use long division method. You can use simplification. It will still give you the same answer. Okay, so we know this angle here is 156. We're not done yet. We just found that angle there. And with that angle here, we can actually find this angle here, which will be now 156 plus 14, which is 170, right? And now if that's 170, and we know the sum of all interior angles in a polygon is given by this formula, we can get the sum, and then once we get the sum, we can divide by, first of all, let's get the sum before I say the rest. So is 180 n minus 2, okay, is equals, now notice the sum is equals 170. That's one angle, but we know if you multiply all angles, it will give you the sum, right? I hope that makes sense. Okay, so this formula gives us the sum of all the angles, right? One angle is 170. Okay, multiply that by all the angles in this polygon. That will be 170n, right? That's the same as adding 170 by all the numbers. If like it's 10 sides, you could just add 170 10 times, right? Which is the same as 170 times the number of times. Okay. Okay, now let's solve this, and this will help us find n. So we can open this bracket. It's going to be 180n minus 360 is equals 170n. Bringing like terms together, I can bring this 170n to this side and this negative 360 to this side. So I have 180n minus 170n is equals positive 360, and then 180n minus 170n is 10n is equals to 60, and then we can divide by 10 here and by 10 here. So n is actually 36 degrees. So this polygon has 36, sorry, not even 36 degrees, sorry. It's supposed to be 36 sides. N is 36 sides. So it's actually a 36-sided shape. Okay. So that's how you solve it. Just remember that formula, you kind of memorize it. Very useful formula for a question like this. I remember it gives us the sum of all interior angles in a polygon. Okay, perfect. So let's carry on. Number 17, you're told B is the point, -3, 1, and D is the point, -5, 9. So BD is a diagonal of a kite ABCD. Okay, let's draw a kite. Let's draw a kite here real quick. I think a kite, my drawing is not perfect. I think a kite should look like that. Usually a perfect kite, let me make this a little bit perfect. A perfect kite, like, it can have two sides which are equal and the other two sides which are equal. And we are told if you were to label this, let's say, let me call this A, B, C, D. And then let's find that line. So we are told BD. So basically we have this point here, which we are told is -3, 1. And D here is -5, 9. Okay. So if that's -5, 9, okay, we're told it's also a diagonal line. So that's a diagonal line. A diagonal line is like a straight line from one end to the other. Okay, so that's a diagonal line of that kite. And we're told the ratio of the length of the diagonal. So we also have another diagonal line, which is AC, basically this one here. Okay, okay. And we're told the ratio is 2:3. So work out the length of AC and give your answer as a surd in its simplest form. Now, remember, if we can find the length of BD and use this ratio, it can actually help us find the length of AC, right? Okay, so let's find the length of BD, and then we're going to use the ratio to figure out the length of AC. So the length of BD, remember, like, you can use 2 points to find the length. And usually, if you remember coordinate geometry, this is actually coordinate geometry, whereby you use 2 coordinates to find the magnitude or the length or the size of a line. And therefore, if we find the size of this line BD, we can help us find AC. So I remember In coordinate geometry, we have this formula for finding the length of a line, L or length square rooted by x2, you can say, sorry, x2 minus x1 squared plus y2 minus y1 squared. We know this can give us the length of this line. So using this formula, we do know if we take the D point to be our 2, so it will be -5 minus -3 squared. So remember this -5 here minus -3, that will be our x2. Our x2 is -5, x1 is -3, and then plus y2 will be 9 minus y1, which is 1, okay, which is 1 here, then we square. So we can now solve this. So this is going to be, okay, this is going to be plus because of 2 minuses, and then it's going to be -2 squared plus 8 squared. So -2 squared is 4, and then 8 squared would be 64, right? Yeah, 64. Okay, so this will be square root 68. And actually, we can simplify these sides. If you know how to simplify sides, you can try to like split it in such a way that one of the numbers is kind of square rootable. And I think 68 can be written as 4 times 17, if I'm not wrong. Yes, because 4 times 17 is 68. And usually 4 is square rootable. So you can say square root 4 is 2. And then, okay, 17 is not square rootable. So, okay, we've simplified the SAD actually. Remember, this is the answer. It's just the same thing. We just simplified the SADs. The SAD. I hope you know how to simplify a SAD. Just basically make one of the number really square rootable. Basically, the largest possible number square rootable. Okay. And if we know this, remember our ratio earlier. Our ratio is 2 to 3. Okay. And if BD is 2 square root 17, actually you can clearly see this is also going to be 3 square root 17 because it's just been simplified. Okay, so our answer here will be 3 square root 17 based on our ratio. So AC is 3 square root 17. Okay, perfect. Now let's move on to part B. So part B says, find the coordinates of the midpoint of BD. Okay, coordinates are easy to find because it's basically x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. So that's the formula we use for midpoint. So our x2, okay, you can take our D point to be 2. So our x2 will be -5 plus -3. So -5 plus -3 divided by 2, and then comma. Now 9 plus 1, 9 plus 1 divided by 2. So -5 plus -3 is -8. -8 divided by 2 is -4. And to put -4 here. And then 9 plus 1 is 10. 10 divided by 2 is 5. And that's the coordinate of the midpoint. So you can say this midpoint here, the coordinate is -4 and 5. Okay, good. Now it says the diagonal AC of the kite passes through the midpoint BD. Okay, so find the equation of AC, now equation of a straight line, and then give your answer in the form of y is equals mx plus c. Okay, now one thing you might notice about these two diagonal lines, and usually diagonals of a kite are always at a perpendicular with each other. And that information is actually important because with perpendicular lines, once you're able to get the gradient of one of the lines, you can actually find the gradient of the other line, because the gradient of two perpendicular lines, like m1 times m2, that is the two gradients, they should give you -1, right? So that means we can actually find the gradient of line BD, because at least that line has 2 points or has 2 coordinates. Okay, so if we find the gradient of that perpendicular line, we can actually get the gradient of AC. And therefore, if we have the gradient of AC, we can use the point, the midpoint, where they share a point, which can also be used to find the equation of both of the lines. But in this case, we're going to use it to find the equation of AC. So now let's find the perpendicular of BD. Sorry, not perpendicular, but the gradient of BD. Okay, so gradient of BD. I think I'm so tired, so messing this up a lot, but sorry. So, so for gradient, we know it's given by this. So M is given, M represents gradient, y2 minus y1 over x2 minus x1. Okay. Now again, taking the D point to be 2, it means y2 is 9 minus y1, which is 1. So this will be 9 minus 1. And then x2 was negative 5 minus negative 3. Okay, because you can see that those are the 2 points we have. Okay, so this will give us 9 minus 1 is 8. So we have 8 over. So this is going to become a plus. Okay, so this is going to be negative 2. So the gradient of BD is negative 4. Okay, so negative 4. So this means if we have the gradient of BD and we use this formula, we can find the gradient of BC. Sorry, SC, not BC. So if we take BD as gradient of M1, I can just write negative 4 here times M2, which is the gradient of AC, is equals negative 1. Of course, if you divide both sides by negative 4, you're going to get M2, that is the gradient of AC, as negative 1 over negative 4, which is 1 over 4. So the gradient of AC is 1 over 4. And actually, if you know an equation of a straight line, M, use it to represent the gradient. Now notice, based on this, we already have our 1 over 4, which is our gradient. And therefore, what we don't have is the C. And actually, the midpoint that we calculated earlier can actually help us find C. Okay, how cool is that? Because we can just use the negative 4 is the X value and Y is the Y value. So if I substitute that in this equation, we'll have 5 here is equals 1 over 4. This is negative 4 plus C. So I think this can cancel. We'll have negative 1 here. We're going to have 5 is equals negative 1 plus C. If you take this negative 1 to this other side, it's going to be 5 plus 6, which means C is, so 5 plus 1, which gives us 6. My brain is working very, very fast. Okay, so C is 6, and therefore our equation will be now complete. So we have 1 over 4x plus, now instead of C, we're just going to write 6. That's our equation. Okay, so this means you really need to get good at coordinate geometry here. It's like this paper kind of tested almost everything in your syllabus. Okay, yes, but at least once you get really good at this, you are able to handle any paper that comes. Okay, now let's go to number 18, and this is to rationalize the denominator, and we simplify it. Now, when you have a denominator like this, okay, we have a plus there. So you can multiply by that tail value, but you're just going to change the sign here, like that. And then remember to do that also to the numerator. Sorry, it's 4 first, minus square root 6. You can actually solve the numerator very quickly, which will give us 20. I don't know why I keep writing that first. 20 or square root 6. Or you can just multiply and you get 80, because 20 times 4 is 80, and then minus 20 square root 6. And then for the denominator, we can expand the two brackets. Okay, so you can do 4 times 4, which is 16, and then 4 times negative square root 6, which is going to be minus 4 square root 6, and then we got square root 6 times 4, which is plus 4 square root 6, and then square root 6 times square root 6, which is that is negative square root 6, sorry. Square root 6 times negative square root 6, which will give us minus square root 6. Okay, think about it as squared, because like you're doing the same thing twice. You're multiplying square root 6 twice, right? Okay, now we have 16 here. Now this is actually going to evaluate to 0, because negative 4 plus 4, or negative 4 square root 6 plus 4 square root 6, that's 0. And then this can cancel, and then it means square can cancel the square. That means that's 6, which gives us 10. Okay, and now let's put everything together. So you have 80 minus 20 square root 6 over 10. Okay, earlier I know I expanded the bracket. I should have kind of left it as 24 minus square root 6. Okay, before. Usually it's good to not expand earlier on because you might need to simplify later on. So I prefer like you don't expand it earlier on, though that's what we did here. But anyway, we just wrote back the original one, because this time I can cancel this. And actually this time, now I have 2 into bracket for square root 6. And at least now this time I can now expand the bracket. So I'll have 8 minus 2 square root 6. That is our answer, 8 minus 2 square root 6. That's our answer. Okay, I don't know why I'm leaving a lot of space on this side. I hope you won't do that. Yeah, but anyway, that's how you solve it. The best way, or the main idea here, is to know how to solve this paper. Okay. Okay, so let's go to number 19. And for number 19, we are given a shape, but it's not drawn to scale. And then the information says, the diagram shows a box in the shape of a cuboid. Mala has a straight rod of length 10 centimeters. So show that this rod does not fit completely inside the box. Okay. So we know, like, this is the highest the box can fit. So that rod can't be put vertically because it's 10. So it's going to be like 3 centimeters outside the box, right? Because this is 7. So the only other way I can see you can put this rod is actually from this end. If you try to lie it to that other end, I feel like that can make a little bit of sense, because we can try to force it that way. And maybe let's check if it fits, because I think that is the biggest way, or let's say the what do we call it? Yes, let's say the biggest length, or the best way to try to fit that rod. Okay? There's no other way actually. Okay, so if we do that, that means let's find out if this is actually going to work and if our rod is going to fit. So first of all, let me just complete this. The reason I want to complete this, because remember we kind of create like we're going to create something like a triangle, which actually we can use Pythagoras theorem for. Okay. Now, if we find this length, we can use now Pythagoras theorem to find this diagonal from this point to this point. And to find this length is easy. You can just use this 5 and this 5 here, which will give us, what will that be? So it will be 5 squared plus 5 squared. It will be that diagonal squared. Let me call that diagonal D. Okay, so it's going to be D squared. So this will be 50, because 25 plus 25 is 50, is equals D squared. And then I can square root. If I square root this, I get D is equals square root 50. Generally, when we square root something, you introduce plus and minus, but we can't use negative here because this is like a real world shape, 3D shape. So just going to be square root 50 here. Okay, we're just going to use a positive version. Okay, now with that, we can actually find now this diagonal line. Again, that will mean, let me call that, I'm just going to use R for the rod. That will be, now we have 50 square root 50 squared plus 7 squared is equals R squared. That is the rod squared, or the length of the rod squared. So this I know can give me, this can actually cancel to be 50 plus 7 squared is 49 is equals R squared. And R squared is equals 99. And therefore, if we square root that, we get R, or the length of the rod, is square root 99. And actually, this rod will not fit. Why? Because actually we are less 1 to 100. Should have, if it was square root 100, we would have gotten 10, and then we would say it would fit. But in this case, square root 99 is basically slightly off. So the rod will not fit perfectly, and it might damage the box. So we can say our answer is square root 99. And we can say this does not fit because, you know, you are being told to show it does not fit. Okay. And this does not fit. Why? Because it's not equals to 10. Because it's not equals to 10. Just give a reason like that. Okay, to 10. And then you get your 3 marks. Okay? Okay. Good. So let's move on. Let's move on. So you're number 20 now. So for number 20, we're dealing with functions. Okay, so functions. So being told to find g of 2. So you already know g of x is 3x plus 4. So that means where there's x, we're just going to replace with 2 or substitute with 2 as the input. So plus 4. This is 6 plus 4, which gives us what? 10, right? So it's 10. So easy peasy. So we go to gf of -1. Okay, this is a composite function. Okay, so this is a composite function. And if you know how to work with function, I'm going to first of all try to figure out what is gf of x. Gf of x before I put the number. So what I do know is usually this inner function becomes the input for the outer function. Okay, so the outer function, we know g, we know g is 3x. Basically now where there is x, I'm going to put the value of f of x. Okay, yeah, so we say we take this as the input for the outer function. So where there is x, or I'm going to put the value of f of x. In this case, f of x is 21 over 2x minus 1, okay, into bracket, then plus 4. Remember, this is still g. You still have that plus 4 there. Okay, so just make sure you understand functions well. If you don't know, I'm going to have a video soon. And also you can leave a comment. I can help you personally. This is 2x minus 1 plus 4. Okay, so at least we have gf of x. Okay, you can simplify, you can try to work things out, you can simplify it, but I'm just going to leave it like that because I'm just going to take this -1 and basically to substitute it here. So it will be 63 over, so we have 2, -1 minus 1 plus 4. So this is going to be negative what? -2. -2 minus 1 is -3. So I have 63 divided by -3 plus 4. So by negative 3, 1 by negative 3, this is going to be negative, is it? Okay, negative 21, yes. Negative 21, because that will be 2 and then 1. So negative 21 plus 4, that's negative 17. And that's our answer. We're going to write negative 17 here as our answer. Okay. Now the other one is an inverse function. Actually this question is asking everything you need to know about functions. Because we have composite function, now we have inverse function. So the inverse function of f of x. So we know f of x is 2 over 2x minus 1. So if you know how to do like inverse function, we know the first step is usually replace f of x with y. So we're going to write y is equals to over 2x minus 1. And then the other thing is interchange x with y. So basically what that means is where there's x, put y, where there's y, put x. So this is going to be x is equals 2 over 2y minus 1. And now make y the subject. Okay, so we're going to make y the subject. And the best way to make y the subject in this case, okay, let's see how we're going to make y the subject. Okay, we can try to multiply both sides by 2y minus 1 and then divide both sides by by x. So if we do that at one go, I'm going to get 2y minus 1 on this side is equals 2 over x. Remember, I've done that at one go. Divide by 2y minus 1 on both sides. Sorry, not divide, multiply. Sorry. 2y minus 1. You're basically doing that on both sides, 2y minus 1. You multiply by that. And after you multiply by that, you divide by x on both sides. That's how you end up with this. Okay. Now make y the subject. This is actually very simple now because we're just going to write 2y is equals, because I'm going to take this negative 1 to the other side. So I'm going to write 2y is equals 2 over x minus 1. Okay. And then I can divide both sides by 2. But before I do that, let me try to make this a little bit neater or cleaner. So the LCM is x. So this is going to be 2 minus x, x, because, yeah. And then after that, I can now divide both sides by 2, which is actually now simple because actually instead of dividing by 2, let me multiply by a half. It's the same thing. Okay. If I multiply both sides by a half, this will cancel this. Multiplied by a half is going to be 2 minus x over 2x. Okay. Okay. Very nice. So far so good. I hope things are making sense. Okay, I've just realized I've been working with 2 here. It's supposed to be 21. But anyway, everything else is correct. All the principles are right. So that's 21. Just put 21 here. It's supposed to be 21y. Yeah, just put 21 where I made a mistake there. This is 21. What else? Where else? 21, like that. Yes. Okay, good. So, yes, so that's the answer. So let's move on to number 20b. So we're told to solve f of x is equals g of x. Basically, what this question is asking you, just equate both of the equation, like this and this one. So f of x is 221 over 2x minus 1. So 21 over 2x minus 1. And g of x is equals to 3x plus 4. So 3x plus 4. Okay, so we can start by trying to get rid of this denominator and just get rid of it by multiplying both sides by 2x minus 1. Can do that here, 2x minus 1. So remember, this can cancel this bracket here, so I have 21 here is equals. Okay, we can expand this bracket, and it's easy to expand. Remember, like you can do that. That's 6x squared minus 3x, and then plus 8x minus 4. So remember, that's how you multiply, so minus 4. So I remember this is equals to 21, remember here. So you can just say, can put the equal to this other side. The note was on the left on this side, but you can just put it on the other side. It's the same thing. So this is x, 6x squared. So that one will give us what? Minus 3x plus 8x, that's plus 5x, right? Okay, plus 5x minus 4 is equals 21. And then we can take this 21 to this other side. We are remaining with 0 here. And then this is going to be minus 21. So you can say 6x squared minus 5x and then minus 25, right? Because this is going to be minus 21 and minus 4, and then this is equals to 0. So here we can use a quadratic formula to find what x is. You can also use the completing square method if you want, but I think the quadratic formula is kind of like quick. You can just use. You can also use the factorization method. You can check, but because I'm not sure and I don't want to waste time checking, let me just go directly and solve it using the quadratic formula. This is minus b plus minus square root b squared minus 4ac divided by 2a. Okay, the formula is, the good thing about this formula is at the front. Let's check there. So b we know is this, -5. So there is already a negative here, and we're bringing another negative, so it's going to be +5. That's one minus. So -5 squared here is going to be 25. And then 4ac, so 4 times 6, that is 4ac. Let me write that here, minus 4. A is 6, C is 20, that is -25. Okay, and then over 2a. 2a is 2 times 6, which you can actually evaluate as 12. Anyway, let's kind of like get, especially inside here. So this is going to be -24 times 25. So that's going to be positive. So I can just do 24 times 25, which will be 20 here because of 2, 10, so 20. Okay, yeah, so 10. Yeah, okay. This is 8, this is 4, this is 0, 0, carry 1, 6. Okay, good. So we know like this bit is 600. So if I were to write this, I would write 5 plus minus 600 plus 25 is 625. Okay, over 12. And I know actually the square root of 625 is 25, by the way. Okay. So on top I have 5 plus minus 25 over 12. So we can start with the plus. So it will be 30 over 12. Okay, and that simplified can be, I can go by 3, 4, then by 3, 10, and then by 2, 5, and then by 2, 2. Right? Yes, yes. So the first answer will be 5 over 2. And now the other answer will be now, okay, this will be 5 minus 25. So that will be -20. So -20 over 12. You can also simplify this. I think you can do by 4, 3, by 4, 5. So you can say -5 over 3. And those should be your two answers. Number 21. we're being told to sketch a cosine graph. And yeah, this is going to be easy because you only need to sketch for how many angles do we have here? We have 0 here, 180, and 360. Those are actually very easy to get, by the way. And if you know like basic trigonometry, you know like if you have y is equals, let's say cos x, we can work with angles that are easy to get, like 0, 90, 180, 270, and 360. So for all these angles, it's actually very easy to get what the value of y is going to be, because some of these we basically actually memorize them, or you can even use the unit circle whereby the radius is 1. But anyway, for simplicity purposes, we're just going to focus on the angle 0, 180, and 270. Okay, although we know even for like we can get for 90, we know for when y is 0 when cos is 90, right? Okay. Yeah, basically just make sure you brush up on your trigonometric knowledge, okay? Especially on cos and sine curves. Okay, so we'll focus on this 0, 180, and actually 360, because those are the ones that we are given. Okay, so we will just use, we know cos, we'll start with cos 0. Cos 0 is actually 1. You can confirm this in your calculator. We'll mark that point there. And cos 180 is usually -1. Again, you can confirm this. And then cos 360 is usually 1. Okay. Even if you want to add for 90 and 270, you can actually do that, because for 90 is 0, so it will be like somewhere there. And for 270 is also 0, it will be somewhere there. So I'm not going to add those ones, but it's just based on the knowledge of sine and cosine curves. So I'm just going to connect those. Gonna be very hard because I'm using a smooth screen, but I'm just going to try. Okay, should look like something like that. And if you know a cosine, how cosine curves look like, that's how they look like, especially for the period of 0 to 360. Okay, so that's our sketch. Okay, good. So for the part B of this, it tells us to solve the equation 2 cos x plus square root of 3 is equal to 0 for basically for between 0 to 360. Okay, so the way we approach this, I want to basically rearrange everything and be left with cos x on the left side. So I'm just going to do 2 cos x plus square root 3 is equal to 0. If I can take this to the other side, I'll have 2 cos x is equals negative square root 3. And I know I can divide both sides by 2. And I have cos x is equals negative square root 3 over 2. And if you know like the trigonometric ratio, you can use even a trigonometric triangle like this one, the one that is usually 2, 2, 2, and then we can cut it in half. We know this angle here is 30, and this angle here is 60. Okay, and if this is 1, this is 1, this is going to be a square root 3. And basically, if you're looking for, if you can see, actually cos 30 is equal to square root 3 over 2, right? But now here we have a negative. So basically here the answer is negative 30 degrees. And again, we are being asked from 0 to 360. So this one doesn't qualify, but there is a simple rule. If you remember, if you have like negative cos x, this is equivalent to cos, we can say cos 180 minus x. Basically, this will give you the angle, the positive angle we are looking. That is usually symmetrical with this one. So if we have cos 30 here, so that is negative 30, this means this is going to be 150. And that's our first angle, by the way. So that's our first angle. So yeah, our first angle there, 150 degrees. And now the other one, apart from this rule, there's another rule we know for cos. Okay, I don't know if I should call them rules, but there's just some things you like can memorize and get to know. The other one is, we know if you have cos x, this is equivalent to cos into bracket 360 minus x. We already have cos x, which is 150, what we've just gotten. So that means if we were to come here, we would get like 360 minus 150, which gives us what? 210. Okay, so the other angle will be 210. But actually, you can confirm. If you try to do this in your calculator, you'll notice it will give you, if you do cos 150, you will get this value here. It will be something like negative 0.8666, something like that. Yes, but that's the value. Okay, so those are the degrees or the angles that are fitting within the limits we are given 0 to 360. Okay, hope that is clear. If it's not clear, try to brush up on your understanding of trigonometry. These things are there, they're taught there. If you need more clarification, please leave a comment and I'll be happy to even make a video about this. Okay, so let's go to number 22. So in number 22, we are told a graph with the equation y is equals x squared plus bx plus c has a minimum point at negative 5 and 12. So find the value of b and the values of c. So the moment you see that word, now you are dealing with differentiation. Okay, you're going to have to find the derivative of whatever we have here. Okay, and that will be our dy over dx, and the derivative of this we're going to have, okay, this is going to be 2x. So if you know, usually multiply this with a number in front here. In this case, it's 1, and then subtract. So if you don't know differentiation, that's the basic thing you do. So you subtract 1. Before you subtract, you multiply whatever you have here with what we have here. In this case, we only have 1 here. Since there's no number there, that means it's 1. Then we subtract. Once we subtract, it's basically going to be x power 1, which can be written as x. And in this case, you're only going to be left with b, because technically here there is a 1. So this 1 times b is just b. And then if you subtract 1, it's going to be x power 0, which is the same as 1. And this will be our answer, because the derivative of a constant, c is a constant, is usually, basically is usually 0. Okay. Now we know this is our derivative or our gradient function. And when we talk about a minimum point, this is the point whereby the gradient is 0. So I'm going to equate this with 0 because we already know the gradient, and this is our gradient function. I'm just going to write 0 there, then 2x plus b. Now, to find what b is, I can take the coordinates of this point, and you can see it's, the x part is negative 5. So if I put negative 5 here, I have 0 here. This is 2 times negative 5 plus b. You can actually see this is going to be negative 10 plus b is equal to 0. And then if I take this to the other side, it becomes positive 10. So b is 10. We've actually gotten b is 10. Okay, the other one, so far we have y is equals, we have x squared plus b, sorry, not b, now 10x, we already know what, and now c. We don't know what c is, but again, if we use again our coordinate here, now we're going to use this one for y. We already have x, so we can use now the two coordinates. So where I have y, I'm going to put 12. And then where I have x, I'm going to put negative 5 again. And then plus 10, negative 5 here, plus c. And if we do this, you're definitely going to get, now you're only left with c, which is what you're going to look for. So we have 12 here is equals, this is 25. and this is negative 50. So basically you have 25 minus 50 plus C. So 25 minus 50 is negative 25 plus C. If I take this to the other side, I have, actually it becomes positive. So basically 12 plus 25, which is 37, is equals C. So our C, we know, is 37. If you were to write the whole equation, it would be like this. Y is equals x squared plus 10x plus 37. So this is the original equation. Sometimes they might ask that. Okay. Yes. Okay. Good. Again, once you see minimum point or maximum point, know you are going to be dealing with, you're going to be differentiating. And in differentiating, you get the gradient function. Once you get the gradient function, the minimum point, whether it's a minimum or maximum point, the gradient at that point is usually 0. Okay. Once you have that knowledge, it's easy now to solve this kind of questions. Okay, good. So let's move on. So for number 23, we are given a shape here. So we are told it shows, okay, the diagram shows a major sector, AOB, of a circle. So the sector angle is 240 degrees and the radius is 12 centimeters. Show that the length of the major arc, AB, is 16 pi centimeters. Okay, so basically you're going to show the calculation that gives you 16 pi. So, and we know going all the way from this to this point, that's the arc we are looking at. So we know from when you're dealing with circles, especially like when you're dealing with arcs and sectors, to get the length of an arc, we usually do theta over 360 2 pi r. Okay, very simple. So in this case, we have theta. Theta is our angle, 240 here. So 240 over 360 times 2 times pi times r, which is 12 in this case. Okay, so this is the equation that will give us. And actually, if you try to solve this equation, and do by, can cancel the zeros, and then by 12, 1, by 12, 3. Okay, and then by 3, 1, by 3, 8. So 8 times 2 is 16 times pi, that's 16 pi. You've just shown that length is 16 pi. Okay, so for part B, OA is joined to OB to form a cone. Oh, okay, yeah. So this can form a cone if you try to like join it and have a cone. So the cone will look something like this. Not perfect, but something like this. Remember, usually the radius becomes the slant height. And remember, we already have the length of this. So if you have the length of this is now a circle. Okay, so that means the circumference of that circle is usually equals to the length of that arc, right? Because remember, you connected from here to this to form the cone, right? So if you have the cone, so it means we have the circumference. And if you have the circumference, it's actually easy to find the radius. Okay, because we know to get the circumference of a circle is usually 2 pi r. And we already know the circumference from the length of the cone, which is 16 pi. So you can do 2 times pi times r is equal to 16 pi. Okay, if you divide both sides by 2 pi, you get your r, right? So we cancel that. So r is equals, this will cancel. So r is 8 centimeters. So our radius is 8 centimeters. From here to here, we have 8 centimeters. Okay, up to that point, we have some information based on, we haven't even looked at the question, but we have information that can be useful in calculating, especially because they're telling us to calculate the volume of the cone. Okay, and then you're told, okay, to give answer in this form. Don't worry about this format for now. We just worry about calculating the volume of that cone. And we know to calculate the volume of a cone is given by a third pi r squared height. Again, we realize we have the radius, we just don't have the height. And remember, this is the vertical height, not the slant height. Remember, the slant height is 12 centimeters. We don't use that one for volume. We need this one. Let me just drop it down. So that's the vertical height. That one is easy to get because we remember we already have excuse me, we already have the radius and we have the slant height. So we kind of have a right angled triangle. We have 8 here and 12 centimeters. So if we can get that height, it will be now easy for us to calculate the volume of this cone, right? Okay. So remember, we already have the hypotenuse. And from the Pythagoras theorem, we know a squared plus b squared is equal to c squared. So if I take this as my a, this is my c. So I'm just basically finding my b. So this will be 8 squared plus b squared is equals 12 squared. So 8 squared is 64 plus b squared is equals 144. So subtract 64 on both sides, or take this 64 to the other side. So you have b squared is equals to what? That 80 is 80. Actually, it's 80. So 80. So to get b, just square root both sides. So b is equals square root 80. Okay. Generally, we would put plus and minus, but because we're dealing with a real world shape, it's always going to be positive. This shape cannot be negative. So b is just square root 80. And actually, you can simplify. This is a surd. So let me just try to simplify it. I know this can be written as 16 times 5, if I'm not wrong. Yes, it can be written as 16. 16 times 5 is 80. And 16 is square rootable, so that will be 4. And then 5. So that's the height. So that's the height. Up to this point, you have some marks, by the way. And make sure your work is neater than mine. And mine is not very neat. Okay, so that's the height. Okay, now we have everything we need to calculate the volume of this cone. So we can say our volume of a cone, going to go here, going to be a third times pi times r. R we got was 8 squared times now our height, which is 4 square root 50. Okay, so this goes on to be, this is 64. So we can multiply this 64 with this. I think that gives us 256. I can do it here. 64 times 4 is 16.1. So it's 24. It's actually 256. So we have 256 here, square root 5. Don't know where this 0 came from. Let's make sure it's not there. Okay, so, and remember, this is over 3, because remember, we have this. And okay, we also have this pi. That pi, we haven't done anything to it. And that's our volume. And actually, if you look at it, remember I told you don't care about this format. You just do the calculation, it will just come. And you can see it has just come. Okay? You can even put the bracket the way they are put, and you're good to go. Okay? So this is Q. It's a volume. Perfect. That was 6 marks. And notice that it's actually very easy to get those 6 marks. Okay, fine. Now let's go to the, this is number 24. I believe this is the last one. Okay, perfect. Yeah, so this is the last one. So you don't find the value of n. Okay, again, we are dealing with indices. This paper has a lot of indices, so make sure you're really good at it. So this is, I'm going to rewrite this as 3 power 3, and then we have nx there. And then also I'm going to rewrite this 9 as 3 power 2. There is an x there, so multiplied by that, and then there is that other 2 outside there. So let me just put this in one go. So this is 3nx is equals 3 4x. Now, because the bases are the same, I can concentrate on the indices. So I know this is 3nx is equals 4 x. So if I divide both sides by 3x, I'll get n here. 3x, 3x here. I'll cancel that. So n is equals, actually n is 4 over 3. So n is 4 over 3. If you want, I'll write it as 1 and 1. And you're done. And you're done with this paper. Yeah. So it was a really packed paper, by the way. I got tired along the way, had to take some rest. But you notice very good questions. It kind of tests a lot on your syllabus. So make sure you're good with trigonometry. Please make sure you're good with indices. Okay? And I wish you all the best as you revise. If you have any questions, if you need clarification on something, please feel free to put your comment down. I'm going to read all the comments. After all, my first video, so I have to read all of them, and I'll be happy to help you. Okay, so that's it. See you in the next video. I'll be making more videos like this in the coming weeks. So please come back and let's learn together. Let's revise this together. And as you keep preparing for your exams, please, all the best. I wish you all the very best. And I know you're going to do very well. Okay, until next time, have a good time. Bye.